Good morning, student. Today we will discuss 12th standard physics, chapter number 1, which is the rotational dynamics. Before study the rotational dynamics, first we know about some basic terms in introduction. First, motion. What is meant by motion? We know motion means what? The phenomenon in which the particle or object changes its position over a time in a given frame of reference. Here, frame of reference. In 11th standard, we also study the frame of reference. What is meant by frame of reference? The reference to describe the position of the particle, which is called as frame of reference. Next, we know about types of motion. There are different types of motion already we studied, but in 11th standard, in the chapter number 3, laws of motion, there are three types of motion: one-dimensional motion, two-dimensional motion, and three-dimensional motion. In a one-dimensional motion means what? All types of linear motion. What is meant by linear motion? The motion of the particle along in a straight line, which is also called as rectilinear motion. Next, two-dimensional motion means what? Motion in a plane. For example, circular motion and projectile motion. That is, circular motion or projectile motion requires two dimension, that is two axis. Next, three dimension motion in a space, that is three dimensional motion requires three dimension or three axis. Next, the half part of the rotational dynamics is circular motion, and next half part is rotational motion. So first we study the circular motion. What is meant by circular motion? Circular motion means what? When any object revolve or moving in a circular manner, the motion of such particle is said to be circular motion. Next, definition. The motion of the particle along the circumference of circle called as circular motion. For example, motion of moon means what? Motion of moon around the earth. Next, motion of earth around the sun. And next, motion of electron. We study motion of electron in chemistry. Bohr's atomic theory. The negatively charged particle, that is electron, which is revolving around the positive charged nucleus, means what? The motion of electron around the positively charged nucleus. Next, some basic terms related to the circular motion. There are four basic terms. First one, radius vector. Second one, angular displacement. Third one, angular velocity. And fourth one, angular acceleration. First term, which is radius vector, and it is denoted by r bar, small r bar. Okay, here two position of particle. A is initial position of the particle, B is final position of the particle. Here particle move from A to B to covers a path, which is also called as arc length, and these two points join to the circle describe a angle. The angle described by two radius vector. First we know about what is meant by radius vector. Radius vector means what? The line or vector draw from center of circle to the position of particle on the circumference of circle called as radius vector. Here two radius vector, OA and OB, means what? O is the center of circle, A is the position of particle on circumference. So OA is a radius vector, OB is also a radius vector, and these two radius vector describe a angle theta, and particle moving from A to B covers a distance S. Which distance? Linear distance. This distance is called as linear distance. Okay, from figure, by simple mathematical formulation, we know arc length is equal to radius into angle. Which angle? Central angle. Okay, therefore arc length here denoted by S. Radius means what? A radius vector denoted by r bar, and angle. Which angle? Central angle denoted by theta. So r bar radius vector is equal to S upon theta. Here S is the arc length, theta is the central angle. This is the final formula for radius vector. Here radius vector means what? A simple distance between center to the circumference of circle. Means what? In SI unit, distance is measured in meter. So SI unit of radius vector is also meter. Next, radius vector is a vector quantity. Why? In a radius vector, there are specific direction from center to the circumference of circle. And last one, which is the direction or the radius vector always directed away from the center of circle. Means what? Its direction is always or directed is always from center of circle to the circumference of circle. Means what? Away from the center of circle. Okay. Next, terms are related to the circular motion, which is angular displacement. Angular displacement denoted by theta. In radius vector, we study the angle described by two radius vector. This angle theta is known as angular displacement. So, definition: the angle described by two radius vector in a given time t at the center of circle is called as angular displacement. Okay, again, the angle described by two radius vector in a given time at the center of circle is called as angular displacement, which is denoted by theta. Okay, by using simple mathematical formulation, we know the formula for radius vector, which is r bar is equal to s upon theta. So theta is equal to s upon r. This is the formula for angular displacement. Okay, angular displacement SI unit theta is measured in radian. Next, direction. Direction of angular displacement is given by right hand thumb rule. What is meant by right hand thumb rule? Thumb rule, imagine that the axis of rotation to be held in a right hand and curl finger around it, and thumb will be outstretched. Okay, simply right hand, this outstretched thumb to be axis of rotation and curl finger around it. This right hand shows the direction of angular displacement and curl finger shows the motion of particle. Means what? The motion of particle along clockwise or anti-clockwise. Suppose this outstretched thumb is in upward direction, so motion of particle is anti-clockwise. If outstretched right hand thumb is in downward direction, the motion of the particle is in clockwise sense. Means what? The direction of angular displacement given by right hand thumb rule. Next, the most important terms related to the circular motion, which is angular velocity, and angular velocity denoted by omega. This is simple definition. We also study linear motion. Velocity means what? The rate of change of displacement per unit time. Same definition is here. The rate of change of angular displacement per unit time is called as angular velocity, which is denoted by omega. So, by using definition, omega, angular velocity, is the rate of change of displacement per unit time, that is d theta upon dt. Simply, omega is equal to theta upon t. This is the final expression or formula for angular velocity. Here, angular velocity in SI unit measured in radian per second. How? Theta is measured in radian and t for time measured in second. So SI unit is radian per second. And dimension here, L. Length is absent, so L raised to 0. Mass is absent, so M raised to 0. Here T, so T raised to minus 1. Next. And last terms related to the circular motion, which is angular acceleration. Angular acceleration is denoted by alpha. Simple definition. the rate of change of angular velocity per unit time is called as angular acceleration. By using definition, angular acceleration is the rate of change of angular velocity per unit time, that is alpha is equal to d omega upon dt. So simply alpha is equal to omega upon t. This is the final formula for angular acceleration. SI unit radian per second square. Here alpha is equal to omega. The formula for omega is theta upon t upon t. Therefore, theta upon t into t square. So SI unit is theta is measured in radian and time measured in second. So second square. Dimension L for length, L absent. M for mass absent. So L raised to 0, M raised to 0, T for time, T raised to minus 2. Okay, next direction for both angular velocity, angular acceleration and also angular displacement. Direction of all these three given by right hand thumb